Okay. So I am, what am I doing here? I don't know. So let me explain what happened. There's a couple of things. Number one, I was supposed to give the drunken rant tomorrow, but instead I am doing it tonight. No, not right now, later on. But in order to prepare for that, I've had to drink. And so unfortunately, I'm a little bit more drunk than I expected to be at the time I would be giving this presentation. So I apologize in advance for the drunkenness of this talk. The second issue is, I don't remember. There were three? So where do I start? So I have this friend named Dan Moniz. Dan Moniz is a really smart guy. Dan Moniz and I we both have the same problem. And the problem is this. We have a tendency to come up with these ideas and say, wow, that's a really fucking cool idea. I really dig this. And spend a bunch of time thinking about, like, what if we implemented this idea? Wait a minute, is that a tab? Are you out of your mind? What the hell is the matter with you? Okay, sorry. So, is this 1985? Okay. All right, so. Whoa. Woo. Okay. So anyway, we have this tendency to come up with these ideas and go, man, this is really fucking cool. I want to do this. I have no time at all. I'm going to try to encourage other people to do it. That's what I'm going to do because I don't have time. And so maybe I'll talk about it. I'll let people know about it, but I'm not actually going to do any work on it because it turns out that I have a day job and a bunch of other crap I got to do. So that's what happens. That's reality. I'm sure many people in this room share this affliction. So I showed up for TourCon last year. TourCon happens to be happening right now, which is kind of annoying. It's kind of annoying. Boo! Yeah, we FPHreakNIC announced our dates first. I'm sure it was an accident. I don't know. Whatever. But in any event, last year at TourCon, I was there. It was in September. Usually is. He did his talk. I was like, that's a really fucking cool idea. I really dig that. I want to help. And I went out and actually bought hardware that I'll talk about in a minute to help with this project. And I was like, dude, I bought hardware. Let's go. I want to help. Assign me a task and I'll do it. And you know, as typical of many of the projects I work on, nothing really kind of happened. And so I showed up for FPHreakNIC, and I actually was going to talk about it, but the problem is the schedule was full at FPHreakNIC, and so I couldn't talk about it. And so I actually, there was someone I borrowed a computer with, and I kind of screwed around with it on Saturday afternoon. You know, in this area, in fact, because this was not where talks were last year, or at least that side. You know, I said, well, a year later, I'm going to come back. Still, this project has not gone anywhere. So I'm going to come back and I'm going to talk about it. And the goal is to try to recruit people to help out with this because I think it's really important. I think it's really interesting. And the whole point of the project is to get a lot of people involved. So that's the goal. It turns out that Dan, this is what happens when you have a deadline. You start doing stuff like about 20 minutes before it's due. You guys know this, right? So I got an email on my Crackberry about 10 minutes ago from Dan where he attached a bunch of fucking code and like was like, dude, I wrote a bunch of code. So I'm going to read this email in a few minutes. And tomorrow, what the plan is, I'm going to talk about this, and then tomorrow when I get up, I'm not going to tell you when I'm going to get up. It could be rough. But tomorrow afternoon, maybe, I'm going to be upstairs, I guess. That's where people are hanging out with their computers and doing random shit. I'm going to have my computer, and I'm going to try to work on this project. And anyone who's interested in helping, please come join me. And hopefully you will, over the course of this talk, decide this is a really cool idea. So what is the fucking idea? What am I rambling about here? So the digital encryption standard, right, DES, was this national standard for doing data encryption. And it was, so here's what the story is. IBM made this thing called Lucifer. That's a weird sentence in and of itself. But IBM made this thing called Lucifer, which is this cipher, and it was pretty cool. They gave it to the NSA. The NSA, it was actually a mistake. I don't know what they were thinking, really, but they were thinking, you know, we can improve this a little bit and give it back to them, and no one will find out how it works for some reason. I don't know why they thought that was the case. It was the 60s. Maybe they were high. I don't know. They took Lucifer. They made some changes to it, and then they handed it back to IBM, and they said, here you go. And what they did is they changed they transposed the S boxes in Lucifer, and it turns out, in retrospect, that they were protecting against a particular attack, which maybe I'll get into, but whatever. They improved the cipher, and this cipher became the digital encryption standard, and then everyone got access to it. And the interesting thing about DES, basically, is that it was, it took 20 years after DES was originally disclosed to the public for someone to figure out why the NSA had changed the S boxes in DES. The reason is to protect against an attack called differential cryptanalysis. And the differential cryptanalysis would have busted Lucifer. It almost busted DES, but not quite. And so, really, it seems like the changes were designed to protect against that technique. And so that caused a lot of people to think that the public cryptanalysis world, the open cryptanalysis world that's trying to understand cryptography, is maybe 20 years behind the NSA. That was the only time that people were able to time this, right? And so the problem with DES as a standard was that the key size was a little short. And this was something the government wanted. So I was recently in Germany. Germany, you know, they had this little spasm in the late 30s, early 40s. Little fascism, little insanity, and so, you know, we ended up at war with them, and they had this thing called the Enigma cipher, which hopefully many of you have heard of, and it was used to communicate to these fucking submarines that were blowing up our goddamn shipping to England, and so in order to stop them from doing that, England actually figured out how to decrypt their ciphers, right? Alan Turing was fucking, I can't give a talk to nerds. They always know some fucking detail. The Polish figured this out. I thought they were conquered. Did they get conquered? Oh, they were Polish people in England. If you were a Polish guy in 1943, England was definitely the place to be. Okay. So, in any event, what's important about this story is that cryptography had a huge impact on what happened in World War II. They would have lost anyway, but the fact is that they lost more rapidly and with less bloodshed on our part because we cracked their goddamn cipher. And so the government had a tendency to view ciphers alongside, say, nuclear weapons as being this significant national security issue. And so in the 80s and 90s, when people started getting computers and started doing things like cryptography on their personal computers, the government was like, what the fuck? Because they treated this stuff like it was a military-grade item. And obviously it's necessary for the Internet, but it was something that they were very careful about. So you couldn't export strong cryptography outside the United States, and that created a lot of problems. There was a lot of controversy about it. So the government said, okay, you can export cryptography outside the United States, but only 40-bit keys. And there was this distributed cracking effort on the Internet that eventually cracked a 40-bit key in a relatively short period of time in order to demonstrate that it was easy to do that, in order to get the United States government to say, okay, fine, not 40-bit keys, maybe 64-bit keys. So in the late 90s, you could export, 64 is incorrect. What is the right number? Is it 56? Thank you. 56-bit keys outside of the United States, and that was really the key length of the digital encryption standard. The actual key, I think, is 64-bit, but there's some bits that are used for error checking. So in any event, that was not satisfactory, and so the Electronic Frontier Foundation was like, this is a bunch of bullshit. We would like to export strong cryptography outside the United States. This 56-bit key shit is not very cool. So we want to demonstrate that this could be broken. But doing a distributed cracking effort with screensavers on the Internet was not a sufficient way to do that. So they decided to build a fucking machine. And they were like, how much would it cost to build a machine that breaks DES, the digital encryption standard. And at the time, I want to make this clear, every bank-to-bank financial transaction was secured with this stuff. Every ATM transaction was secured with this stuff. This was the way that financial transactions were protected. And so they built this computer, and they actually published a book. And this is the book called Cracking DES. This book includes, how many people in this room know what VHDL is? About 20%, 30%? VHDL is a programming language for hardware. It's a way of describing a digital logic device. And you can write VHDL, and you can send it to people in Asia, and they will send you back a chip. So, so this thing includes VHDL code for a chip that cracks DES, and they built an array of them, and they spent about $250,000, and they built something that could crack DES in about 8 days. So that was a pretty significant thing, because the question had been, how much does it cost? So who can afford to spend $250,000 on a DES cracking device? I can't. The mafia can. The Russian mafia. By the way, if anyone here is actually from the Russian mafia, I would really, really deeply appreciate it if you didn't sort of get busted by Symantec exploiting, what is it, real media on fucking Friday. Because I got a weekend here, and I just, why don't you get busted on Monday so that, we can work on it on Monday instead of having your exploit discovered on Friday? That really sucks. What? You're right, but that's a different story. All I'm saying is that, like, one way or the other, I'm a computer security professional, and I'm unhappy about the fact that the mafia got busted on Friday. Why don't they get busted on Monday? Anyway, so anyway, where was I? DES, 56 bits. $250,000. The mafia, maybe a major corporation, right? Maybe certainly the NSA. Of course, they probably did back in like 1983. I don't really have a significant amount of money to contribute, but I can probably do some of the work. If you have no, I'm just kidding. No, so so at that point, $250,000 gets you into every bank in the world. That's probably a problem. And so that's why we have AES. At that time, NIST, as a response to this project, said, okay, fine, guys, we'll make a new standard. And the encryption standards were weakened. The export rules were weakened. Who is the senator from Nevada? Where's Timball? He lost in 2006. There was this Apfelwein. I'm doing a technical talk. This isn't my rant. Thank you. This man. Sorry. I'm too sober. This man has brewed some very, very fine alcohols, and I'm very happy about that. What? No. There was this guy who was like a Montana senator, a Republican. He was mostly responsible for in reaction to this, basically getting the government to liberalize the export standards, and then he got nailed in 2006 in the Democratic Revolution. So, not that I'm unhappy about what happened in 2006, but there was a few babies that were thrown out with the bathwater, and I think he was one of them. But in any event, no, I'm talking. I'm doing a talk here at the con. So, in any event, this was a really interesting project. So my friend Dan said, well, it's been almost 10 years, hasn't it? It's 2007. And he was like, I wonder how much it costs to crack DES today. That's an interesting question. What is the story today? And so what he wanted to do, this cost about $250,000. He was like, let's reduce this by an order of magnitude. Let's crack DES for $10,000. It's kind of an interesting idea. And so he came up with a way to crack DES for $10,000, and that's really what this talk is about. And he talked about it at TourCon, and I think it's a great idea. And unfortunately, one of the things that happened to him that I think probably affected his motivation was that it turns out some guys in Europe did it first. Some Germans, as a matter of fact. Some Germans did it first, because Germans are superior. So, in any event, they spent about 8,000 euros, which at the time was about $10,000. Now it's probably $20,000 or $30,000. I don't know. But they spent about 8,000 euros building a desk cracker using precisely the same hardware that he was talking about using, as a matter of fact. I do sound like a silly German. Did you not hear my talk earlier about St. Polygo? So, anyway, whatever. So this is the thing. Let me explain how he wanted to approach this problem, and let me explain why I think it's still relevant and why I'm trying to get people to look at it as an issue. The way that he wanted to do this, how many people in this room know? I mean, I already asked who knows what VHDL is. Who knows what a field programmable gate array is? Not bad. Not bad. I'm going to explain it. I'm sorry. There's some people here that don't know. So a field programmable gate array is a... Well, let me step back a little bit. So when you're looking at a mathematical problem that you could implement with an algorithm, there's pretty much two ways that you could solve this problem. You could solve it with a von Neumann machine, which is like your Intel processor, which is a general purpose computer that could solve any sort of mathematical problem. Or you could implement a specific digital logic solution that is only capable of solving your specific problem, but probably solves it faster. In a microprocessor, you have this thing called a pipeline. And, you basically, for every instruction that gets executed in a microprocessor, you have this process that it goes through where, memory is loaded out of registers, and then it's fed into this arithmetic logic unit where some stuff happens, and then it goes, and maybe some other stuff happens, and then it gets loaded back into memory. And there's this process. Your megahertz on your CPU is actually this clock signal that moves data through this pipeline. And and so each stage of this pipeline, there are these things called flip-flops. They're essentially memory units where this thing is stored here, then it goes through this digital logic, then it's stored here, then it goes through this digital logic, then it's stored here. If you have like a digital logic implementation of your problem, you don't have this pipeline. One clock cycle, and you can push the inputs all the way through the circuit and get your output at the end. And so essentially it's faster. The downside, of course, is that that's all it can do. You've made this hardware device that does one thing. You can't play video games and word process. But if you're trying to do something fast, like cracking DES, it might make sense to do this. So a field programmable gate array is an interesting technology because what it lets you do is take this hardware implementation, instead of making ASICs that implement this specific problem, you can buy this thing called a field programmable gate array, which is sort of like this empty space upon which you can write a specific circuit. And then later you could write a different circuit. And then you could write another circuit. And so it's not as flexible as a von Neumann machine because you have to reprogram it every time you want it to use it for a different problem. But it does, and it's not as fast as an ASIC, but it's somewhere in the middle. And so that's kind of cool. Traditionally, these were used for prototyping, right? And I'll do a little bit of technological prognostication here. Traditionally, FPGAs were used for prototyping. If I was an engineer in a lab and I was designing a processor, I would want to write it to an FPGA and test it before I told people to make 100,000 of them to make sure it was working right. But FPGAs are too slow for me to use in production. Well, what's increasingly occurring is that FPGAs are getting faster and faster as Moore's law moves forward and FPGA technology gets more sophisticated. And so you can actually use them in production environments. And so, for instance, I saw a telecom switch And, you know, maybe you want to provision a pot circuit to somebody's house. Maybe you want to provision a DSL circuit. And so they had one piece of electronics that was connected to the circuit, and they would push down a different, it had an FPGA, and they would push down a different FPGA image depending upon what kind of circuit that particular customer wanted to buy. So that's kind of cool. I think someday, in your PC, you'll actually have a bunch of FPGA space that you'll manage like memory, and you'll swap processes in and out. So if you're running Photoshop, maybe some of your Photoshop filters will be implemented in hardware, and you'll have this virtual hardware space that can be loaded into when Photoshop is swapped in, and when Photoshop gets swapped out, you swap in, you know, your web browser because you're done working for the day and you want to look at porn. You know, the Photoshop filters will be taken out of the FPGA, and something else will be brought in. So that's what I think is going to happen. I think investment in FPGA companies is probably a good idea in the long term. But this idea is really exciting to me. What Dan wanted to do is take a bunch of FPGAs and get a bunch of people on the internet to each have one plugged into their computer, and take the deep crack VHDL code that cracks DAS and load it on each one of those FPGAs, and then over the internet coordinate the distribution of key space and the cracking thereof. And so you could build a sort of, you guys are familiar with SETI at home. You've got this distributed effort where you've taken this problem, you distributed, and you know, lots of different people are working on small parts of the problem in order to find the solution. Let's do this with hardware instead of doing it with software. Problems that are good at parallelization, that are suited for things like SETI at home, for things like screensavers, are also suited for this kind of parallelization, and are way, way more efficient this way. I wish I had the numbers in front of me, but the numbers were something like, I need to think about this. The like orders of magnitude. Having these hardware devices hooked up to individuals' PCs is orders of magnitude more efficient than using screensavers, because again, your problem, instead of going through this pipeline, is implemented in hardware, and one clock cycle gets you an answer for each question that you ask. So the problem is that these fucking Germans managed to crack DAS for $10,000, and so if we built this computer, we could not go out and say, hey, we're the first people to crack DAS for less than $10,000. What we could say, why do people insist on interrupting? I'm drunk. I can't. I'm trying to do a talk. We'll talk about this later. That's not much. I should drink more. It's probably because I didn't do it right.
Correct. I blew a .12 on.
Let's try this again. You've interrupted it now, so.
You gotta wait 5 seconds.
I thought I was supposed to wait 15 minutes after drinking. 0.11, that's much better.
You're not driving anywhere.
No, I'm not. I'm trying to give a talk. I'm not driving. Am I? I'm not driving, right? No, I'm not. This is not a car. It's not a truck. It's a series of tubes. How am I doing on time here? Good. So I went to TourCon and I saw Dan when this idea is Dan's. He gave this talk at TourCon last year, and I was like, this is fucking fantastic. I want to participate in this. And let me explain why. It's not about cracking DAS. Fuck the Germans. Okay? This is a way to start the project off because we already have the VHDL written. We just need to load it on some chips. The advantage is building this distributed FPGA-based computer with a lot of different people who have FPGAs out there that are willing to take shards of these distributed computing problems, because it's way more efficient than doing the screensaver stuff. And so you can take problems like protein folding, and maybe SETI at home if that's what you're interested in. It's very important because, soon aliens are going to invade. The thing is that you can take all these really interesting parallelizable math problems, you can solve them way faster than you could before. The other thing is that I think you get to leverage a bunch of people who are interested in VHDL, who are interested in Verilog, who are interested in FPGA engineering, who do not get to apply their skills. Is there anyone in this room? Is there anyone in this room who studied computer engineering in college? No, that does not count. Were you required to write either VHDL or Verilog for a class? Couple people. Do you do that for a living? No, you don't? I thought you were one of the ones who did. You don't anymore. See, no one actually gets to do this for a job. You study this, you learn how to do it, you don't get it. No, shut up. You shut up. No, what? I think that's TCP/IP. Look, that's later. At 9 o'clock tonight, you can ask questions like that. What? I never worked for Intel. Let's talk about that later. I don't know what you're talking about. If there is a human being on this planet who has remembered every single Intel instruction, no one knows. I'm just saying. I don't know him. All I'm saying is that no one actually knows all of the instructions that can be executed by an Intel processor. There are things hidden in the microcode. I guarantee you. Hidden. We're way off topic here. So, FPGAs. The point is that you can build this really efficient system for doing distributed computing that is absolutely a step forward in terms of technology, in terms of distributed computing. That you can solve distributed problems much faster than anyone has ever solved them before. And that to me is really exciting. It's actually a technological advance, and it's actually something that this community could do that would have a significant impact on what? I have it right here. The hardware costs about $150. This is it. This is an FPGA prototyping board from a company called Xilinx. And if you go look at the FreakNIC website, I actually advise that people buy these. Did anyone actually buy one? Did you buy one? Let's not get into that right now. Oh, that's not good. Who wants to take this from the drunk guy? Does anyone want to see this? Are you guys... Can I pass this around without somebody dropping it? Yes. Here. So that's a... Don't... I want that back. I'll fucking kill you. So... There's a lot of people here who have a lot of access to things like credit reports. Really? No, no. I mean, that's that's a. Oh, right. No. You're right. If you're an asshole, you can call them up and you go like, I work for Scientific Atlanta, and we're gonna buy like 1 million of these things, and I need one of them to do a prototype, and they'll like, yeah, sure, dude, we'll send you one. You're right. I mean, why would you? This is a good point. You can, in fact, get these at reduced price or free or next to free by... There you go. You're a recruit. You're joining the project. So, I think this is really exciting because I think this is really a technological advance. This is an opportunity to solve certain distributable mathematical problems faster than anyone has ever done so before. And this is something the hacker community can do. And I think that's awesome. And so the key is we need to start somewhere. We need to actually solve a problem and demonstrate that we can solve a problem and that we have people who are involved in a project and we have the software infrastructure. And once that's done, then other bored people who studied computer engineering in college that want to write VHDL, want to write Verilog, that have no outlet for that in their life because they're programmers now, will write implementations of things like protein folding, or other problems that are distributable in this way that will help cure cancer, find the aliens, or whatever it is that we need to do as a society. And so cracking DES is the easiest of these problems. Now, the problem is, as I started out beginning talking about, is that Dan and I share this problem where we have this tendency to look at an idea and say, that's really fucking cool, and have no time at all to do it. And so Dan actually did some work, it turns out, and he sent me an email about 10 minutes. I got an email from him this morning, which he sent at 1:45 last night, where he was like, dude, I'm going to work on this. I'm going to pull it all nighter, blah, 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 blah. When's your talk? And I'm like, dude, my talk is at 5 p.m. this afternoon Central Time. And so he's like, okay. I've got a bunch of SMS messages from one guy in the back of the room. I'm not going to read them. Should I? I'll get to them in a minute. I have, so 10 minutes before my talk starts, I get this email from Dan. He says, hey, Tom, I'm still troubleshooting. I'm going to read this. I have not read this email yet, frankly. I'm going to read it out loud to all of you. He says, hey, Tom, I hate you. I don't want you to work on my project. You're a fucking... Oh, wait. Maybe I shouldn't read that out loud. No, I'm just kidding. That's not what it says. So it says, I'm still troubleshooting synthesis problems with my various cores. I reverted back to an older open-source GPL test core, and it needs tweaking as it's using about 110% of the available resources of the field programmable gate array that we decided to use. But it's closer to working than the current dev cores using Xilinx ISE Webpack. Webpack is the free edition for low and medium density designs available from Xilinx's website. I do most of my dev in the 4Pay ISE Foundation edition on another laptop, but I wanted to make sure that these cores would synthesize and be fully usable from Webpack, because Webpack is free and he wants people to join the project. The website isn't up due to some website management issues on our end, but those should be fixed in the next couple of days. For now, I'd recommend collecting names and email addresses of people who are interested, and we can ping them about the cheap crack list once it's back up and running, and about the master FPGA hacking website list. This is the website I alluded to, which isn't up yet, but in essence it'll be a dedicated website with news and resources for hacking on FPGA projects. Not sure what you have planned to speak about, but from the title and description of the talk, I gather you'll at least partially talk about cryptanalysis with FPGAs in large, i.e. not just about cheap crack. In that vein, actually, I did kind of just talk about cheap crack. There are other people doing cryptanalysis with FPGAs, but we won't get into that. In the vein, definitely mention that NSA at home is an interesting project. That's a good point. Especially for the JTAG reverse engineering tools Dude developed. Plus, there's some brief overview of the history of the cheap crack slides I did for TrueCon, at least as pertaining to influencing cheap crack. Let me know how it goes. I'd definitely be interested in a debriefing when you have some time. I'm attaching a snapshot of the current GPL testing core Webpack project just in case you find it handy to have people to bang on it. It's configured for the FPGA that's on the S3 board, which I'm passing around, which hopefully they blah, 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 blah. Even though it's not fully bootstrapped and toolchained, it's something to show people that's probably better than nothing if anyone can tweak it to synthesize on the FPGA board and they have a digital USB data board, blah, blah, blah. I continue to work on building a complete documented board support package with working cores, interface dev tools, etc. That's the email. So we'll get to that in a minute. So the bottom line is that I have a bunch of interesting code for Dan that he wrote today that relates to getting cheap crack working on these FPGA boards. And what I'm going to do is when I wake up tomorrow, I'm going to go upstairs and I'm going to try to get it working on that board. And, you know, if this is something that interests you, if you're interested in field programmable gate arrays, if you'd like to see the hacking scene make a fundamental advance in computer science, please join me. Help me figure this out. I don't have time to work on this project, and so what I decided is that I'm going to spend tomorrow at FreakNIC working on it. And anyone else who's interested in contributing, please come help. and let's try to make something happen here. I think it's really interesting. I think it has a great potential. And apparently Dan has done some interesting work that we'll get to pick apart and try to make some progress on. He suggested talking about this thing called NSA at Home. This dude got these weird FPGA-based boards off of eBay and wrote this thing called NSA at Home, which does, I think it's MD5 hash cracking. And it's actually a really neat project. He's got a lot of details up on his website about how it works. It's not very reproducible because the hardware platform he used is really weird, but it's interesting, and it's an example of the potential of this. There's lots of people in the hacker scene kind of screwing around with FPGAs as a way of doing bulk cryptanalysis, rainbow tables, stuff like that. There's lots of neat projects in that vein, but I think this is the best one. This has the most potential. This is the thing that has the potential to change the world. So I'm going to be working on it tomorrow. Anyone who wants to join me, please do. And that's pretty much this talk. I should read the rest of these SMS messages, and then I'll take questions. So let's see. What do we have? Christopher V. I'm fucking rock hard right now. Thoughts? Woo! It's like, I don't even know what this means. I think MT rectum prolapsed. What should I do? You got to be sober enough to actually type the SMS messages correctly. Good, because whoa, I get a picture of him pointing at me. What else do we got? There's a message that says, suit up. And then there's, I've got another message that says, stop disrespecting my wife. Who went to SummerCon? A couple people. Okay, so, I'm sorry that I'm more drunk than I wish to be when I was giving this talk. I have to be drunk because I'm supposed to be drunk later on for the drunken rant. I hope that this was useful and entertaining. I really am excited about this idea, and I would like to make some progress on it, but as many of you are probably as well, I'm very busy, and so I haven't had a lot of time to do some stuff. It sounds like Dan did. We'll have some code tomorrow, and I'm going to play with it, and we'll see if we can get it working. And I think there's some real potential to this. Who's got questions? 8 days. They could crack desks in 8 days. No. The cheap crack, the deep crack, the original EFF project. No, I think it was faster than that. The book's right here. Who wants to look it up? Hey. No. I was slower than the deep crack, but it was fast enough that if I could get your ATM transaction in 8 days, I'll own your ass. It's good. No, so triple DES. You mean triple DES or AES? Oh no. That's 56 bits. That's not the 40-bit weakened version. That's the full 56-bit version. Now today you're going to be using 128-bit keys. What? No, they were not doing a distributed thing. They took the same field programmable gate array and they built their own custom motherboard and put a bunch of them on the motherboard. And they spent 8,000 euros building this motherboard with these FPGAs. So it's not a distributed thing, and it's not something that can be... I think that we can get more FPGAs by building a real distributed project, a community of people that are interested in this than the Germans had. And we can solve problems faster. But they were just doing a if we had $10,000, what could we accomplish kind of project. Unlike them, we don't actually have $10,000, not individually anyway. Although I'm taking donations. Who's next? Questions? Someone had questions. That's a great question. I don't know the answer. It depends on... Yeah, I don't know the answer to that question. Yeah. It takes a long time to reprogram them. They will run fairly quickly today, but the actual reprogramming is a slow process, and so you get into this task switching issue. Right. Once you loaded your circuit in, then it would be very fast to use it, but it would only be useful for one math problem. So you got to decide what math problem you want to load. I'm getting kicked out. What? No, milliseconds. What's your question? Yeah, milliseconds. Just infinite. Yeah. No. You can reprogram it as many times as you want. It's slower than actually running instructions. Yeah. Yep. Instantaneously, it's faster than your CPU. So I'm going to be upstairs working on this tomorrow. Anyone who's really interested in this, I think it's a cool idea. Thank you for your time.
Lady. Wait. Ladies and gentlemen, I have a public service announcement. This was not by design, but fortuitous luck. We are sharing the hotel with one and only one other group this weekend. And I want to let everybody know you're not that drunk yet.
Yes, I am.
However, we are sharing the hotel with circus clowns. I have already encountered more than one in full dress. There is a circus going on at Municipal Auditorium across the river this evening. So when they come back, all in one car, there should be quite a few clowns in full dress. We'll see how many of them we can get drunk this evening. So that is our new mission. However, if you see a clown, it's not because you're that drunk. You have something to add to this?
I have a question.
I would love to hear your question.
Where's my board? Thank you. You guys didn't fuck it up. You're not totally crooked. Thank you. I'll see you guys tomorrow.